Hi, I'm Vijay Rao. I'm part of the Li2 team, and I'm here to conduct the workshop on designing and building physical objects. I come from a background of mechanical engineering. In the past, I've been part of teams that have designed gearboxes, and I've also been part of uh, designing 3D printers with my company, Brahmatri. Um, So great. With that introduction, let's begin. There are a bunch of things that I will take you through today, right from what we have done in the past in terms of design and go towards what the design process is and take you through CAD and 3D printing. So that's the direction. So to give you a rough idea of the content that we'll be going through today, first, I think there's a lot that we can learn from how design was happening before the introduction of computers. So this is where we will begin to see what kind of features or what kind of highlights we can take from there. And then we will continue further on how design is happening today and go further. So we start with design before the introduction of computers, then how the design process has been since the introduction of computers. From this, we extract what are the elements of good design. Then I take you to through a design process, a very basic process, but this should give you a good detail on what are the things we need to take care of in a design process. The tools commonly used. I think this is something that quite a few students have been asking us on what tools and what kind of softwares do we use and under what stages of uh, design do we use. So this is something that I will take you through. Then I'll explain the design process through a very simple example of a gearbox, an automobile gearbox. Should give you a fair idea of this is through my personal experience. This should give you a fair idea on how this can be applied in actual design. Then we will have a session on CAD modeling, primarily through Fusion 360. Then there's quite often this debate on whether we need to do 2D drafting or whether we need to do 3D modeling. So I will give you an idea of what you should choose or what you can choose under what circumstances. Finally, we go into 3D printing because that is one of the easier methods to bring your design to life, at least today. So we will tell you what kind of 3D printing processes are there, and then we will close the session with interaction and with any doubts that you might have. Someone is on mute. Can you just mute it, please? Great, great. So let's begin. So this is the agenda for today. At any, as I told you earlier, at any point of time, if you have any doubts or you want to ask me any question, please stop me. I absolutely don't mind that. You can stop me and ask me any kind of doubts you have. Okay, so with that, let's continue further. So first we'll start with design before the introduction of computers. So before computers, primarily any designer or any engineer or any person who would be part of the design process would use a drafting board and drafting tools like paper, pencils, stencils, compass. These are things that they would use. So it was quite extensive earlier. This was anyway the only method that time. Uh, the views that they would do would be your 2D views because you can't replicate a 3D model on a drawing board. So they would draw different views. When I say views, you have a top view, you have a bottom view, you have your side views. So they would put in these views to give a clear understanding of what the design was about. At certain times, they would do elevation. Elevation is giving a look of a 3D on a 2D drawing. So they would do that at times. This was a specialized process. When I say specialized process, people wouldn't directly jump to a drawing board and start drawing. They had to imagine something. They had to imagine how their views would be. So quite often, only authorized personnel could make drawings. And in terms of altering, if a drawing had to be altered, we just no one could just go in and check the drawing and say, okay, instead of this dimension, I will add this dimension. It had to go through an authorization process, because any change is happening physically on paper. It is not that simple where you could erase that change and then come back to it again. Uh, So in the drawing itself, quite often they would maintain a version control. Somewhere in the drawing, they would identify an area where they would uh, identify the changes that were made in the drawing and the date on which the change was made. So this was quite clear so that anyone who refers to that drawing understands, okay, yesterday the dimension was this and today the dimension has been altered to this. Uh, so that way they would give crisp, clear instructions. The idea of doing these drawings was to give out information to people who were seeing the drawing to understand what the design would be. So the instructions were clear, crisp, and since these are big sheets, they would quite often be stored in drawers. You can see a picture of the drawers at the bottom. So these kinds of drawers, they would store all their drawings in. So this was how design used to happen before the introduction of computers. In fact, even the maintaining was on papers in a drawer. Then transferring or replicating these drawings or giving these drawings to someone was an issue. That's when the drawings started going on microfilms.
Excuse me,
Uh,
sir.
yes,
Sir, before this you said no, sir. Designing before the introduction of computers.
yes,
Is that similar to machine drawing like that, sir?
yes, it is. It is. That's why today in machine drawing, they teach you these tools simply because these tools have a good what do you a good way of giving you imagination, right? You have to imagine and drawing. So it's a very good way of building that aspect of design. So the first year when you are in engineering, quite often you have to do machine drawing with these drafting tools. Earlier, without computers, this was common. Right now, you either do it on the drawing board or you go to the computer and do it on AutoCAD. But yes, you're right. This is similar to what you do in machine drawing.
Thank you, sir.
In turn, as I was saying, the drawings were then were moved to microfilms. This would help in replicating the drawings, would help in easily transporting the drawings to your customer or to anyone to view them. So these were done with punched cards. As you can see on the right, there's an image of the punched card. So the punching was primarily to have some data on the drawing. Maybe it's the drawing number or something, and the microfilm area had the complete drawing. So you could either view the drawing in a card sorter machine. You had a card sorter machine, or you could use a lens, a magnifying lens, and a light source. You could then view the drawing as well. This, so the drawing slowly progressed from storing it in paper to storing it in microfilms. This was primarily for storage. This was primarily to replicate. This was primarily to make sure that it can be given to people much easier. Yeah, as I said, these are called aperture cards. So before we go into what design is today, let us see what the features of the previous system was. One, it was manual drafting on paper. Uh, so as far as manual drafting on paper is concerned, the process was iterative. It was time consuming, as you can imagine. Any mistake can be really expensive. When I say really expensive, if I have to change a dimension to something else, it had to be communicated to a bunch of people, because it wouldn't have been easy to tell anyone that I'm changing this design to this or this dimension to this. So it would have been a really expensive process. So quite often before you make the design, you have to be conscious about what goes in. You have to make a plan. You have to understand, okay, these are the kinds of views I need, these are the kinds of details I need, this is the kind of information I need. So although it was a progressive step, the kind of thought that had to be done before starting the drawing would have been quite a bit. This was quite often done by qualified individuals, qualified not in terms of only education, but more in terms of a basic drafting knowledge. So people had to be strong in their fundamentals, primarily geometry. Uh, you need to have an understanding of how to draw a triangle, how to draw a circle, how to draw a square, what a line is, what fits and tolerances are. People needed to have that kind of information at their disposal. So they had to plan it out and decide first. The work that was done was quite original and genuine because drafting is an art. It is not something that uh, you can develop overnight. It is something that evolves. So it is an art. So it was quite often considered original and genuine. And they would go to designers that were very specific to that kind of design. So there was a feel of creative style and expression. Uh, the idea behind 2D drawings in those times were primarily to deliver information. If I have to make a drawing and if I have to tell you what it is, I have to make sure that the drawing has all the details that you possibly may have doubts on. So it was a lot more detailed. It had to be in such a way that it delivers information. So over the time, every template had a basic structure. There was a universal way of representation, a region where the actual drawing would come, a region where the material details would come, a region where the company details would come, a region where the version controls would come, uh, a system of what kind of fits, what kinds of tolerances. So slowly a universal way of representation developed. So this gave good clarity and it eventually led to good quality design because these elements were coming in directly. There was a strict version control. At any time anyone would make a change, they had to write down what change they were making and where they were making changes. So quite often they would represent it by alphabets whenever they make a change, and they would mention the zone in the drawing where they made a change. So people, when they saw the tab where the version control was, they could directly go to that area and understand, okay, this is the change. So if this person is making this change, and since my component is part of this, I'll have to make a change in my drawing too. So people would maintain version controls earlier. This was physical. When I say physical in nature, it was directly on the drawing. These were stored in drawers and aperture cards. And I mean, aperture cards have 500 years of lifetime. And it's even today, there are numerous companies in the world that still use aperture cards to store drawings. It's a very safe and foolproof way of saving drawings, and it can be maintained over a longer time frame. So these are the features that came in the past. So from here, I want to take in a few elements that I think are strong in terms of what we need to have even today. So some of the key takeaways from what people were doing in the past would be one, more conscious of what goes in, right? Highlight, I've highlighted it in the right side. Uh, People had to be conscious of what goes in. Then strong fundamentals. Uh, you first plan and then you decide and then you proceed further. This is something that we miss out today, which is to detail and deliver information. I don't think nowadays there are companies that do that well, not that they aren't, but in general, the design has become uh, less informative. This is something that we need to learn from the past. And all this led to good clarity. And finally, we get a good quality design. So these are some of the takeaways that we need to have uh, even today going in our designs today. So now that we understand how design was before the introduction of computers, let's just compare that to how design has been since the advent of computers. As you can see, some of the pictures over here, you have 2D drawings and you have 3D models. That's what computers have bought. And then, yes, you can also do drawings on the computer with templates, with all the information necessary. So 2D drafting and 3D modeling, 3D modeling, of course, is solids, and 2D drafting are done by curves and figures. So you have a bunch of CAD softwares. The 2D softwares use vector-based graphics for drafting, and 3D softwares use raster graphics, which is dot matrix, uh, to give you the overall impression of the look and feel and what we have with the 3D models today. What the good part about using computers for design is that it's possible to visualize across multiple locations. It's possible to visualize something that someone else has done right at maybe your home, your office. So this is what the computers have got us today. Uh, yes. So we have computers also provide a database for storage. Uh, you can replicate the drawings, but we have to be careful over here because quite often it's difficult to maintain version control unless you have a process to it. So this is where I think to some extent the previous way of doing things, which was on paper, had a better version control possibility. But yes, all said and done, computers have brought about a lot of change and a lot of advantages to the way we have been doing design in the past. So let's get to the features of the system. When I say the system, the features of the system when design started with the introduction of computers. So we had you could do 2D drawings, you could do 3D designs, you could also do analysis. I think one of the main advantages of computers is that you can use analysis softwares to check the strain, check the load, check the bending, check a bunch of features. Uh, which wasn't possible earlier. Earlier, it had to be tested through physical prototypes. So it has become time efficient and mistakes can be corrected easily. So if today I understand that this dimension is just not working out, it's not giving me the necessary fit or the necessary assembly features, I can go back and say, okay, let me alter this design to make sure that I come up with a design that really works well. So this is the advantage of today's system. Digital documentation. So it allows for real-time collaboration across locations. It saves time and money. Storing paper in big drawers is expensive. Storing aperture cards is expensive, while having digital documentation has been a lot easier just with a computer. So it saves a lot of time. It saves a lot of money. I can easily go ahead and discuss my designs with someone staying in Europe, maybe someone staying in US, maybe, or anywhere in the world. So it actually saves a lot of time, and that is increased security as well. We can have password protection and a bunch of things that could be done through computers. So work can be copied, it can be shared, which some say might be a boon, may not be a boon, but it's at least easily accessible. It's at least available. So we can have multiple people work on the same design, unlike earlier where a design would happen on a paper where they had to collaborate on a deeper level to make sure that the people involved are on the same page. Today, people can work parallelly on designs. Uh, Design flexibility. It is easy to change and upgrade designs. So, as I told you earlier, even one person can design while all you can also have a full team to design. Like some of you are in automobile engineering, and I think one of you is also working on a car design. So you all those are collaborative. So today's design allows for that because you have tools available at your disposal to make that happen. So you can have discussions, you can make design enhancements, and you have access to the design and build. So these are advantages. And in addition to this, it also you have uh, you can easily research online and upgrade your design. So this is what computers bring to design today. So now let us take some elements that are important to the design process from this system. One is time efficiency. This matters in today's world. People, whenever they want something coming to life, the kind of time frames that people work with are really, really aggressive. So in that case, you need time efficiency. So depending on computers is a wise thing to do in that aspect. uh, Design through computers, the good part is that it allows us to change or upgrade designs, and you can easily make design enhancements through discussions. So now if we combine what we learned, what the key takeaways from the previous uh, method before the introduction of computers to the key takeaways from now, uh, these are your elements. So these are the things that we highlighted from before and after. So these are the elements of a good design. Yes, there are others, but I'm talking primarily in terms of putting things on paper. So you need to have strong fundamentals. You need to plan it out and decide. You need to be more conscious about what goes in. You need to be time efficient. You need to detail to deliver information. And when I say information, it should include everything where another person who's reading it for the first time and may not even know you should be able to understand what was in your head or what kind of design you came up with. Uh, then it should be easy to change and upgrade designs, good clarity, and design enhancements through discussion. So all these put together make good quality design. So these I would say are elements of good design. Great. Uh, does anyone have any questions? If anyone has any doubts as we progress further from here, I will be moving to the design process. So if anyone wants to ask doubts, anything, please do ask, and I'll be more than happy to answer them. Great. So let's continue then. So as I told you, these are the elements of good quality design. I've just put it as a tab, as a table, but these are the elements of good quality design. So once we understand the design, now how do you convert that into a good quality product? So you'll have the ones. So you bring in the manufacturing, you bring in the assembly, and from design it goes to a good quality product. Yes, having a good manufacturing facility, having access to good assembly facility is important, but all these put together give us the good quality product. So now that we understand the elements of good design, let us maybe go a bit deeper into understanding what makes a good design. Now, yes, I know it has to be time efficient. Yes, I know it has to deliver information, but what kind of information, or how do I make that happen to make sure that these quality parameters are met? So this is what the design process would be. Okay, now before we continue further, I must tell you that this is a rough direction. You can always come up with alternatives. You can always uh, interchange each of them, but I think a general direction uh, can be maintained. So, what's the idea behind design? Uh, it's about creating something that works according to our intended purpose. So today, if I want to design something that moves, and I have a motor, I have a bunch of gears and things like that, eventually when I build it, it has to move the way I thought it should, right? So that's the idea behind design. That's the idea behind prototyping and manufacturing. So now going deeper into what the design process has, uh, or the entire process of from the concept building to uh, going to the final product, you always start with a basic concept, irrespective of what kind of design. You might be designing a gearbox to designing a basic housing or a casing for an electronic PCB, but it has to go through certain direction. You start off with a concept identifying critical performance parameters. You identify a functional direction, you identify a logical flow. It can be rough on a piece of paper, but you need to include those elements that you think are critical to the performance of your final product. If this stage is not done well, it can lead to something in the future where you say, oh, I have to come back and tweak the concept again. So this is an important phase. So you start off with a basic concept or a direction. Then once you have a basic, say a block diagram or anything like that, you start adding to it. Once you know what are the critical parameters, you start adding to it. You start adding the actual components. So maybe from just saying, okay, I need to uh, current needs to be transmitted from point A to point B, you start saying what will you use to make sure that current is transmitted. Or if you have to move from point A to point B, you start adding, okay, I need this gear, I need that gear, or whatever. So you start adding components to it and you start detailing the concept. Now, again, over here, when you detail the concept, you have to work towards including all the critical information. You validate the direction. This is basically saying, okay, if I go in this direction, I know I can achieve what I intend to achieve. That direction has to be clear. That direction should be a known path. Until it is a known path, you need to work on this to the more time you spend over here, the lesser uh, trouble you will have in future. So you detail the concept. So once you detail the concept, you move towards finalizing the concept. You finalize the concept, you finalize the assembly check. So you detail the components to scale. For example, if say earlier you just said I need a gearbox to do this, in as you finalize the concept, you start adding the physical dimensions also to the components. You start building it to scale. And as you're doing that, yes, quite often it happens that we may not have the necessary information or necessary uh, skill to say this would work or this wouldn't. This is where you do some kind of basic validation. You either validate it through a study. There are numerous research papers online, there are numerous designs online. So you start validating it through a study. It can be a deeper study into the basic concept, or it can be a comparison. So if I'm designing, say, a gearbox. So I can compare it to another gearbox that is in the market to see, okay, if that gearbox is working, then my gearbox should work. So you can take these kinds of privileges, and these privileges are necessary because you can't go behind first principles on every aspect of design, because it takes a lot of time. But you can be a bit smart in terms of saying, let me actually take this direction because this is already available, this is already working in the market, so my design should work. And then add your elements to that design that adds better features or anything else. Then you can also validate it through tests. When I say through tests, you can, at this stage, just to understand whether your concept is in the right direction or not, you can build very basic prototypes that don't necessarily need a lot of investment. But these are prototypes just to say, if I want to move from point A to point B, is my concept making me move? So you don't have to build an entire design, you just have to build that performance parameter. So you can either build it through 3D printing or basic CNC machining, or a basic PCB, anything. But you need to validate, if possible, if you have the luxury, then you need to validate it through basic tests. So this is where you finalize your concept. Now, once you finalize your concept, you move into detailing. But before you move into detailing, you have to ensure that your concept itself has all the information available. When I say all the information available, all critical parameters that are important for your design to come to life should be mentioned in the concept. If you don't finish the stage, I suggest, this is through experience, I suggest that you don't go into detailing your design, because you'll always end up coming back to it where you'll have to detail out more than what you expect. Okay. So once you finish finalizing the concept, you come to detailing on the performance features. You start with the performance. When I say performance features, there are some uh, some portion of the design which is critical to it functioning, and some portion of the design it is more aesthetic, or it is not very critical to your performance. So start detailing those parameters or those components that are critical to the performance. Here, you also need to understand the kind of manufacturing process that you have access to and the kinds of budgets you have available. You can't go behind designing something with really, really good precision tolerances and say, I will use a very basic um, machine which doesn't give those uh, parameters. You can't go behind that and say, I want a really, really high finish when the machine is not capable of doing that. So it is extremely important for you to understand what access you have, whether you have access only to 3D printers or you have access to laser machines or whatever. So you need to understand that access, and also budget. You can't design something, start detailing it out where the entire design costs, say, a lakh of rupees while you have only 10,000 rupees in your pocket. So it's extremely important you start designing keeping these in mind. Uh, Please understand that these are critical aspects. You can't go out of the way and say, I will make the best design and let us see what happens. It generally doesn't work like that with the kind of time frames we have today. So yes, so once you finish detailing on the performance features, you start detailing on the remaining features. So there are features that are not, as I told, may not be critical for the performance. You start detailing that out. So before you detail the remaining features, make sure that your performance parameters are met. So if you see the entire design process so far, by the time you've detailed on the performance parameters, you have to make sure that your performance is met. That's the direction. Then you start detailing the remaining features, and that's where when you add the remaining features, you have to ensure that there is no performance that is hampered. Any portion of your actual critical design shouldn't be affected by you detailing out the new features. Then you have, once you detail out the remaining features, you have a final assembly check. You validate it on manufacturing. You do a final assembly check and check if uh, you've maintained correct tolerances. Check if two components are coming together. Once you manufacture them, you should make sure that they have the necessary fit. If you want a transition fit, you give a transition fit. If you want a clearance fit, you give a clearance fit. So you have to make sure that these aspects are met in your design. It is not a wise way to work where you allow this decision to be taken by the manufacturer. You as a designer should ensure that under any condition of manufacturing, these aspects of your assembly are met and they shouldn't affect the performance. Then once you finish the final assembly check, uh, you figure out who your manufacturer is and what kind of information they would need, and make sure your information, whether it be a 3D model or a 2D drawing, is given in a direction that the manufacturer can understand. So this is one of the aspects that we had earlier mentioned about designers doing that in the past. They detail it out to give information. So make sure that your design is in a way where it gives the necessary and relevant information to the manufacturer. So once you manufacture and you test, what you need to make sure is you validate your assumptions, you update the design, and you have version control. Now, this design process is a very basic design process. I also understand that maybe when you're detailing out, you might go back to altering the concept. When you're manufacturing, you might go back to finalizing the concept. These things will happen, but nevertheless, these are aspects that you have to go through. You can do mix and matches, but these are aspects that you have to go through. Does anyone have any doubts here? Great. We will continue then. So please remember you can stop me anytime. Okay, anytime you want me to show the slide for an extended time or anything, please let me know and I'll do that. So amongst this entire design process, what I would personally say is the most critical would be where we finalize the concept and assembly check. We have to make sure that all the information is there before we start detailing. This this at least today in today's design, I've been part of multiple design processes, and I've quite often seen that people rush to detailing, people rush to getting it manufactured without actually having gone through the stage where they conceptualize it in detail. So this is something that I would say as people who might get into design in future, you all should make sure that this happens and happens really well. So here we finalize the yeah, as I said, this is the most critical, finalizing the concept and validating it. So now to have all this done, we need tools. And when I say tools, I'm talking about primarily softwares. This has been a question that people have quite often asked. What kind of softwares do we use? So just to tell you, for the basic concept or the direction, quite often you can start off with a basic design input document, which identifies, okay, this is what I have and this is what I have to build. So it is a design input and a requirement document. It can be a Word, it can be anything, and or a basic block diagram that shows a flow, shows a direction for someone who is looking at it. For someone outside who's looking at it from a bird's eye view, they would want to see, okay, okay, the A is there, B is there, so I'm getting C. So I think a basic flow, that's where you start. For detailing the concept, if you're moving from a basic concept to detailing it, you can use a 2D concept sketch. So quite often you can also use pen and paper. Quite often in this stage, at least for mechanical designers, AutoCAD is used as a 2D drafting tool. So uh, in this stage, you detail the concept. Uh, for finalizing your concept, you quite often either use a 2D concept drawing or a 3D concept model. People nowadays are comfortable using 3D modeling, so there's absolutely no issue with this. We just have to ensure that once you make a 3D model as a concept, you also generate a 2D drawing to ensure that all the information is given, because quite often when you do 3D modeling, the necessary information, maybe be it on the fit, maybe be it on the surface finishes, maybe be it on the material, all these are difficult to identify at one go. So it's a good practice to have where from a 3D model you also generate a 2D drawing with all the necessary information. For detailing on the performance features, quite often we use detailed drawings, or 2D detailed drawings, or 3D models, or you can also assist it with some amount of analysis through a software or through comparison. Because as you're updating your design, suddenly you find, okay, maybe the wall thickness in this area is less. I should increase it. So these kinds of details can also come through your analysis. So you need to go through that stage where you do a study during your design. Similarly, while detailing on the remaining features, you use similar tools. You use your 2D detail drawing or your 3D model, or you do your analysis through software and comparison. Yeah. On your final assembly check, there are different things that you can do here. One is you can have a 2D drawing of the assembly and drawn to scale. When I say drawn to scale, if you're drawing a box of 20 centimeter by 20 centimeter, on the computer when you're drawing it, you have to make sure it is 20 centimeter by 20 centimeter. It shouldn't be something else where it just looks like a box. It should actually have the actual dimensions. You can even draw it to half the scale or double the scale if the objects are really small, but you need to maintain a certain scale. So your final assembly check can be done with that, with either a 2D drawing or a 3D model or something called stack analysis. Stack analysis is a quite often an Excel sheet. It is also done on 2D drawings, but it is basically talking about every critical dimension and their tolerances and see how each of the uh, fits are happening. I will anyway talk about this further in the example that we go through. So for manufacturing and testing, during that, now this possibly might be the first time you're heading into a physical object, unless during the concept building you are making a basic prototype. If not, this might be one of the critical times that you have to ensure that certain assumptions are met. So have a parameter list, have a critical parameter to check and see, okay, is this met? So if a particular dimension is important, go back and write that in a piece of paper and go to your manufacturing. Once the manufacturing is done, maybe assemble it and then see, okay, this is met. Have I got the value that I wanted? So start validating all your parameters. Make sure that you have these documents with you. Yeah. So does anyone have anything you want to ask? Great. We'll continue then. So this entire design process, now I will explain it through an example. So here I've taken an example of a gearbox. So I mean, for those of you who may not be aware, a gearbox is the one that I've highlighted in the red box. It's a simple unit that comes after the engine, and this is what helps the car moving forward at different speeds. Now moving forward, backward, anything. So I'll take a simple example of a gearbox and show you how the design process is applied to that. This should give you a fair idea of how you can do it in your own designs. So what I have on the left side are the different areas of design, of the design process. So first we start with a basic concept or the direction. So as I told you, you start off with a basic block diagram, right? A basic block diagram that talks about what inputs you have and what is the requirement. Here on the right side, if you see, I have 4 blocks. These are all representative values. I've just given it only to help you all out. So it has a block diagram where I've told that the input parameters are the engine power, the engine torque. So you need to have an understanding of what that is, what the vehicle weight is, what the axle ratio is, what the tire size is. These are possibly the inputs that go into building the gearbox. And on the right side in the red box, I've mentioned what the requirement is. We need a uh, counter shaft gearbox, how many number of speeds, what the when I fit the gearbox, what should be the maximum vehicle speed, within what kind of volume the gearbox should fit. So this can be a beginning to what you design. You need to have a basic direction. So a simple block diagram identifying the available details and make a design input and requirement document. So for this particular thing, the tools that were used were maybe a PowerPoint slide or a Word for documentation. You can also use online flowcharts for this. It's really up to you to decide. Continuing with the same basic concept, this is another way of representing, which is not necessarily a block diagram. This is just an Excel sheet where we have all the information. When I say everything, it has everything. Now, the areas that uh, are covered in the gray box are additional areas because which I haven't shared here. But these are additional areas. So if you have a lot of information, you can actually make a sheet like this which talks about all your details. So a table. So the tools that were used over here were primarily Excel and Word. So it's a good beginning uh, to start off with collecting all the information you have. More the information, better it is for you to take judgment calls. Next, we come to detailing the concept. So now that you have a basic direction, you have a block diagram, or you know what you need to do, you start slowly detailing the concept. What we have done over here, in any vehicle, the main aspect of the vehicle when people talk about it is power, and power is made up of speed and torque. So when you start off with a design on a gearbox as an example, since I've taken the gearbox as an example, you start with a basic diagram that tells you, okay, if this is the speed that I'm giving the shaft in the beginning, what's the speed at the output? Or if this is the torque or power that I'm giving, what's the power that I will get in the output? So you start identifying a basic flow diagram. This is a basic uh, 2D diagram that has been done called a speed and a torque diagram, which talks about it's a basic line sketch which talks about the movement of um, speed and torque. So the primary feature of a gearbox is the gear train. Any gearbox, you talk about multiple gears meshing to each other, and the speed and the torque determine the performance of the gearbox. So now that I've identified what is critical to the performance of the gearbox, I start working primarily on those concepts to make sure that those concepts are met, and that is my speed and the torque. Then once I make a basic sketch, I can also have a table like what I've shown at the bottom, talking about the different gears and what kind of teeth it has, what are the number of teeth, because speed and torque depend directly on the number of teeth in the gears. So I can start making my own calculations. Sorry. So the tools that were used here is AutoCAD for 2D drafting, uh, Excel, Word for documentation. And so what you need to do is make sure that you highlight the functional direction. So anyone has any doubts, because this might be a bit technical. I don't know if you come with backgrounds of knowing about gears and things like that. So if any of you have any doubts at this stage, please let me know. It would be great to answer them.
So
But what
please
I
explain the torque diagram, sir.
So the torque diagram is, so torque in this particular case, this is a gearbox, which is an automatic gearbox. And in an so today when you sit in a car and you shift gears, you shift between your first gear and your second gear and your third gear. There is something called a dog clutch that is there inside the gearbox that helps in moving the control from the first gear to the second gear. In case of an automatic transmission, you have something called a clutch housing. So if you see in the top diagram, if you see C1, C3, C2, C4, C5, these are your clutches. And if you see G1, G2, G3, G4, these are your gears. So in the top diagram, when I say I have my input shaft. Input shaft is the shaft that comes from the engine. And my output shaft is the shaft that goes to the wheel. So if I want a certain torque to be met in the beginning, in the first gear, when you're in the first gear, you generally have more torque and less speed because you need that kind of push to begin. When when you're in the second gear, slowly the amount of torque you need is lesser and the speed you need is more. So when you come to the fourth, you come to the fifth gear, you generally go at higher speeds because that time the torque requirement or the power requirement, I would say the torque requirement is a lot lesser. So what we do in the torque diagram is we tell, okay, if the input shaft is getting so much torque, is giving so much torque, which are the clutch packs that I engage? In other words, you can also call it dog clutches for uh, easier right now. So which are the dog clutches you engage to make sure that the output shaft gives you higher torque? So that's what the torque diagram does. So I show, okay, I will engage in the table. I say, okay, I will engage C3 and C4 and C5 to give me this gear. I will engage C1, C2. When I say engage, it means holding them together. Okay. So that's what the torque diagram does. Similarly, in the speed diagram, I tell when my input shaft has so much speed, if I engage the gears G1, G6, G8, and G10, I get so much speed. Instead of G6, if I engage G1, G7, G9, G11, I get so much speed. So you start building that aspect into the design. Uh, I hope I'm decently clear. I understand that visualizing this might be difficult, but that's the direction at least. Is that fine?
Yes, sir.
Yeah, if you please ask me if you have any more doubts. Uh, I can maybe once this session is done, maybe I can take you through how we do the talk diagram further and things like that. I'd be more than happy to do that as well. Is that all right? Can I continue?
Sir.
Great. So now we've done a basic detail. When I say a basic detail, this necessarily doesn't have all information. What this diagram has is only the number of teeth on the gear, because that's the primary thing behind calculation speed and torque diagram. If you've studied mechanical engineering or anytime come across gears, you would have understood that T1 by T2 is equal to speed by speed or torque by torque, whatever, inversely proportional. So the number of teeth is the primary key in this. So you just start deciding on the number of key to begin with because that's a performance parameter. Then you move towards finalizing the concept. Please understand that here, when we are finalizing the concept, we still haven't begun detailing the component. I haven't told what material it is. I haven't told a bunch of things, or I haven't started 3D modeling it. What we are still detailing the concept to an extent where I can take any information from this concept and easily detail out my component for manufacturing. So if you see this particular diagram on the right, I'm sorry. If you see this particular diagram on the right, it talks about the gears and it talks about the clutch pack similar to the speed and the torque diagram. If you see over here, C1 and C2 is similar to the previous drawing. I'll just go back. The previous drawing on the right side, C1 and it should be C2, C1 and C2, right? So this is that area itself, the top area of the concept that I showed earlier. Now I'm detailing it out. If you see the previous sketch on the right side, you find G3, you find C1, you find, I hope you can see my mouse. So you find G3, you find C1, you find G4, you find G5. Similarly, you find G1, G1 and G2 are the gas and C3 is the clutch pack. And you have the input shaft. So what I'm showing here is the same thing. I have G3, G4, G5 gas, C1 clutch pack, G1, G2 gas, and C2 clutch pack. And this is my input shaft. So I'm just showing you a portion of what we mean by detailing out a concept. Now here what I've told in the gearbox as an example, because this is an example, we won't go too technical, but it's important for me to tell you what we mean by detailing, right? So when we talk about gears, we talk about the number of teeth on the gear, we talk about the size of the gear, and size is governed by a parameter called module. But irrespective, we primarily say how many teeth are there on the gear and what the size of the gear is. So if you see over here, that is what we are talking about. Any gear, that is what we are talking about, right? All the gears. So these are the details. Here I haven't told what should be uh, the material. I haven't told what should be the surface finish. What I've told primarily is only what are the performance parameters. When I say performance, critical to ensuring that the concept direction is met. Similarly, in terms of these are the bearings that go on the shaft, right? So I've told what kind of bearings I will use. Uh, right? Then and critical dimensions. So this is critical to me. I haven't told all the dimensions of the gear. If you see, this is the gear. I haven't told all the dimensions. I've told those dimensions that I think are important. Now, why is this dimension as an example important? This is the width of the gear. A width of the gear is very important in terms of the stress or the load it can handle. I can have the same size of the gear in terms of diameter and lessen the width, but it may not handle the load that is coming on the gearbox. So these are all the critical parameters. These are my critical dimensions are mentioned in this concept layout. And all these drawings, all the gears, all the sizes are done to scale. When I say done to scale, if for example, I've said the gear OD, this outer diameter is 172 mm. So I literally draw it to 172 mm. It's important that you draw everything to scale and make sure that those important parameters are that. This is what I mean by detailing the concept. as you understand, this is not enough for a manufacturer to build, but this is important for you to progress. And from here, it is very easy for me to go and detail it out. And tomorrow, if I want to change it, I can easily come back to the concept layout and say, okay, I had decided on this as the parameter. Now I have to change it as this. I know what my designs will look like. So this is what I mean by finalizing the concept and doing an assembly check. So uh, as I've told on the left side as well, update the concept drawing to scale and with as much information as possible. This is a critical stage that is quite often ignored. At least today, we find quite often that designers directly go into 3D modeling or 2D drawing, which is absolutely no issue, but they fail to identify all the necessary information, all the information that is critical to the performance. This is something that I would suggest as people who may be heading into design in future. Don't ignore, irrespective of whether it is mechanical design or whether it is PCB design or whether it is any kind of design, make sure that this stage is done well. So the tool that was used here primarily was AutoCAD for 2D drafting. Note, you can also use 3D modeling software, but ensure that if you're using a 3D modeling software, you make a 2D drawing out of it. Because as you can see, for me to tell you information through this drawing is a lot more easier. Instead, if I had a 3D model of this entire thing, it would have been difficult for me to tell you what size it is, what parameters go into it. So ensure that your 3D model also has a 2D drawing, at least in the concept stage. Yeah. Any doubts? You can ask me because a few of you may not be familiar with these items, and I'm happy to go back and forth just to answer them. So let me know if you just want to check a few things and want a better idea of these things. I'm sorry. I'll just wait for a couple of seconds. Great. I'll continue then. So from finalizing the concept and the assembly check, we move into detailing. Now, when I say detailing, we are detailing more at the at the component level. So if you see, a gear train is typically has gears, right? So you talk about detailing gears or you talk about detailing components. So the pictures on the right side that you see are the all the dimensions that are given. For example, the width of the box on the top, 18 mm, or the distance between the holes, and all these things. So this is what detailing would mean. Ideally, detailing should be done on a 2D drawing. Your 3D models will have all this, but it's sometimes difficult to relay information to people who, if someone wants to just understand what is the distance between these two holes, it's easier to through a 2D drawing that is readily available than through a 3D model. So detailing the components with the important parameters taken from the concept layout. So once I have a concept layout, it's extremely easy for me to detail it out because I have things to scale. Then the tools that were used here were primarily 2D drafting through AutoCAD and Autodesk Inventor for any other 3D modeling software. Frankly, you can use anything. You can use CATIA, you can use Unigraphics, you can use Fusion 360, you can use a lot of tools. There are enough tools available in the market. Uh, You can also, during this stage, you can also use analysis softwares for validation and ensure that you're making a drawing highlighting all details. As I told you, it's a good practice to have, irrespective of whether you start with a 3D modeling software. It is a good practice to have to make a 2D drawing for you to understand whether things fall in place. So these are basically views of the drawing. This is a front view, this is a top view. So these are views of the drawing. I'll go further. Any doubts? Great. So I'll go further then. So Now we come, once we've detailed out all the we've finished the concept, we've finished detailing out the components. Now you do an assembly check also, right? You can do the assembly check even after finalizing the concept. uh, you can do it anytime, frankly. Once you have certain critical parameters you understand, you can do this check. Now quite often the assembly check is done through something called stack analysis, okay, where you identify all the important uh, dimensions. For example, this is the shaft on which I've fitted two gears, and I have a bushing in the center. Okay, so if my shaft dimension, this is 45 plus minus zero point 0.5 mm dimension, I have to make sure that once I put the gear, the bush and the gear, I have a small clearance to allow for manufacturing tolerances. When I say 45, I can't make the dimension when I'm manufacturing exactly to 45.000. There will be certain amount of plus minus tolerances, so you have to specify that in the drawing. And in the worst condition also, you should make sure that this gear doesn't come out of the shaft, else you can't put this end spacer at the end. So that's how it is. So this is a typical way of doing a stack analysis. What you can also do is take all these dimensions into an Excel sheet and make a list of, these are my dimensions. So if I do 30 minus zero point 0.2 and 30 plus zero point 0.2, it would be 29.8 and 30.2. You can say, okay, when I have 30.2, these should be my dimensions of the gear, and when I have 29.8, this should be my dimension of the gear. So you can do a stack analysis of this. And for doing this, you need a good understanding of what kind of manufacturing tolerances you'll achieve. If you're using, for example, a CNC machine, your tolerances that you achieve can be a lot tighter. If you're using a 3D printer, generally they tend to have wider requirement in terms of tolerances. So you really need to understand what kind of manufacturing you're going ahead with it to make sure that whatever tolerances you're giving in the drawing are up to your liking. So do an assembly stack analysis. Include all component tolerances in the assembly area and ensure that the correct fit is obtained. The tools that were used in this are AutoCAD for 2D drafting, Inventor for 3D modeling, and Excel for calculation. Yeah, so this is a typical way of doing a stack analysis, and this is true for anything. If you're making a casing for a simple Raspberry Pi, as an example, you're making a outer casing. Even there, you have an area in the Raspberry Pi where there is a USB port. You have to make sure that when you're assembling the two components, that USB port is open so that when you put the wire, it doesn't foul with the casing. So this is a simple area where you can use an assembly stack to make sure that you put the dimensions in and ensure that under any condition, you can always meet the necessary requirement. So here you also need an understanding of the budget that you have for manufacturing. Yeah. So do you have any doubts here? If you do, please ask, because I've been going through a few technical things, so I would be more than happy to answer any kind of doubt that you have. Great. Shall I continue then?
Yes,
Great.
sir,
I'll do
please.
that. Yes. So now that we've done an assembly check, now we are ready to go into manufacturing. Here you have different options available. As a student, quite often you get to 3D printing or you do laser cutting, but you have different kinds of options available. Um, so you manufacture and validate your assumptions, have a critical parameter list and a validation list, and update designs. So you can use your CNC machines. CNC machines are computer numerical control machines, or you can use your conventional machines like your lathe, which doesn't have a computer interface, but it is more of a manual operation. Then you can use laser cutting, you can use 3D printing. There are quite a lot of options available, but at the time of design, you need to understand what option you have available. Even budget plays a role over here. So don't ignore these areas and don't directly get into design saying, I will design the best and later whatever happens will follow, because you need to make sure that you have access to the tools that you want, or you understand the tools that you have and design accordingly. So, during your concept stage and during your design phase, you can always talk to the manufacturer and understand what they have and understand what kind of instructions they need and make sure your design caters to those instructions. So this is something that happened to me even during the gearbox design, which I was part of. We made sure that we spoke to the manufacturer to understand the kind of tolerances that he can achieve and made that available in the drawing. It is extremely important that we take this phase important. Take it, don't take it lightly, rather. Okay, so this is the entire design process, and this is an example of an overview of how it was done for a gearbox design. So now we go into CAD modeling. So here now that we understand what the design process should be, we'll go a bit more detail into the kind of tool that we will use. And here we primarily will take you through a session of Fusion 360 just to give you a basic understanding of design and how you can do 3D modeling. AB has joined us. AB is one of the founders of AlphaBot. It's a company primarily working a lot on robotics. They've built their own set of robots as well. So he will be taking you through Fusion 360. He's worked extensively on it. So he will be taking you through some of the common tools that are available for design. And if you all have Fusion 360 part of your machines as well, you can as he's doing things, you can also go through it on your machines. Over to you, AB.
Yes. So good morning, everyone. So let it be an interactive session. So you can stop me whenever you need the clarity on any of the topics or anything. So I'll give you an overview of how to use this tool, Fusion 360. So this is basically a 3D modeling tool that you can use to design your, like you can change, like you can make concepts, like concept models. Like you have an idea and you want to see how it will be manufactured or how to make that into a product. So you can do all those kind of designs in Fusion 360. So instead of make iteratively making a hardware and going through all the steps, you can actually make a model first on Fusion 360 or any other CAD modeling softwares, and later you can go to the hardware part. So in this session, I'll give you an overview of how to use the tools in Fusion 360 and the environment which is being shown. I guess everybody can see my screen, right? Okay, so let's start with the session. Okay. So Fusion 360 is like a cloud modeling system, so in which you can actually create a design. You can share the design also, but all the things that you do will be done on the cloud, so you don't have to use your local computer processing for all the processes. So like even you can use this design what you have designed in another system also, like a different system, or a friend of you who has access to this project also can use this design and make modifications. So it's very easy to collaborate in this software. Okay, so like when you open Fusion 360, probably this will be the environment that you see, and then to the left you see the projects. Actually, if this is not visible, you have to click on the tab, show data panel tab at the left. Sorry, like there is some voice interruption. Then you see there are projects, list of projects that you have done. Okay, and if you have to create a new project, just click on the new project icon, and then you can name your project. For example, TQB. Okay, so this is a new project that I've created. Okay, so just a minute, I'll be. Okay, so this is the new project that I've created. So you can see the project as blank. So if I want to like invite my friends who use Fusion, or like the collaborators, other people who collaborate with me in the project, I can go to people and I can just type in their Fusion 360 mail ID and I can invite them. So they can also collaborate with this project. So this is the project that I've created. And if I have to upload a already existing models, like you get models from GrabCAD or any other, you get multiple models online. So if I have to add those models in Fusion, like just click here to upload, and you can either drag the file directly from the desktop, or you can just select them in the file location. Okay, like just you can open all those and you can just select those. What, just yeah. So this is all about the like the project panel that you see. You can also close the panel and just this is the complete design environment that you can work on. Then coming to the, so I'll just take you through the basic environments. So there are multiple environments that you can see. So this is the solid environment. So where you have to, like if you want to make a model like with the dimensions driven, you can use the solid environment. So for example, you want to make a cube and just make modifications to the cube and all those, you can use the solid environment. Then comes the surface environment. So surface is where you draw a 3D drawing. So in solid environment, you use 2D drawing and like you make a 3D model out of a 2D drawing. And in surface modeling, what you do is you draw a 3D sketch. From that, you patch it, like there's some operations called patch and all those. So you can connect all the points in the 3D sketch and you can make a plane. So that is using surface modeling. So you have to sketch multiple planes and all those. So that is like to the next step. Like it's initially it's better you start with the solid modeling and then you can go to the next. You can explore the tools like surface modeling and all those. So coming to the sheet metal, so this is basically like as it says sheet metal. So if you want to make something out of sheet metal, so sheet metal is basically like, you know, you get a sheet, you take a sheet that can be of any material and you bend them to make a model. So in like there are some rules that are to be considered while making this. So all those are there in this thing, like this tool. So there are like you can draw a sketch, you can bend a part of that, like so you can actually make something like this in like so making objects like this you can use the sheet metal option. And then tool is basically to get an idea of how you manufacture it. So when you manufacture it, if you are using the modern tools like, you know, CNC and all those, CNC or 3D printing, you can actually simulate your model and like how the manufacturing is going to be done in this environment. Okay. And these are all at the top. So you can see like there are four options at the top. So I'll go back to solid. So you can go to the topics just by clicking those, and then there is a drop down to the left also. So you can see there are about 6 drop downs. So first is the design. So by default, when you open Fusion, you will be in this environment, basically design and solid environment. And then the drop down, there are multiple like rendering, animation, simulation, manufacturing, and drawing. So basically what each means is like in the design, you can design a new model. After you design the new model, you can create a image or a video of the model that you create in an exact environment. So how it will look. So if you have to show someone what you have made, like you can give us lightings and all this stuff. So most of the products that you see around, right, like the advertisements and all those stuff, so they actually generate a rendered image, the photo of, like they design the 3D model and they develop the rendered image and that is being shown. So you can like, it's like just for showing what your model is with the materials and all those stuff. So you can apply materials to your model and just generate the rendered images. So the next is the animation. So if I click on animation, so and if I have a model, I can have a animation of the model. So we'll go in detail, or like I'll show you all the this thing in the coming steps. So there are multiple options, simulation of, so you can analyze the structural analysis and all this in simulation. In simulation also there are a variety of simulations like the thermal, model, static, electronic cooling, and all those. And the last is designing, drawing from the design and animation. So you can create a drawing from the design that you have. So so you can so basically for manufacturing you have to generate a drawing that they can understand. So for that we use that tool. Okay, so starting with we have created a project. So now we'll create a file also. So this is the file that we are gonna create. So uh, so you can add a extra file by just opening a new tab. Okay, just so just by adding this, you create a new design also. You can close that off. Then, so for first thing for making a 3D model is you need to have a 2D sketch. So first, so this is the sketch options. Okay, so you can click on the sketch. So this creates a 2D sketch. So there are 3 planes as you see: XY plane, YZ plane, and XZ plane. So you can select one of the planes on which you want the sketch to be. So if I click on this, so then I can draw on this. So if I have to go back, or if I want to click on something else, like if I want to draw on this plane, I just have to click on this. So and I'll click this. So the options on top changes now. So you can see there are options, variety of options here to draw and all this. So now I'll select, I just want to draw a rectangle. So different options, like there is a line option, rectangle options. All these are geometries that are you can directly apply to so first I'll start with rectangle. So if I have to draw a rectangle, there are multiple options like a 2-point rectangle. So if you're familiar with CAD before, you can use any of these. Like you will be familiar with all these, but if you're new to it, you can just explore by trying out different tools and all those figures and all this. So I'll just start with the center rectangle. So in this, there are 2 points that I have to give. That is the center point from which that is the origin of the rectangle, and the final point. So this is how I draw a rectangle. Okay, so either I can enter the value of the dimensions of the rectangle here itself. Like if I want it to be around 200 and 200 by 100, 200, after typing 200, just click on tab and just type in 100 and enter. So the rectangle is being created. And the panel you see at the right, these are just the viewing options. So if I don't want to see any points in it, I can just remove those, and the dimensions and the constraints and all those stuff. So these can be done in these so these are basically for viewing and all those. And if I have to draw a circle or something, I can go here, or I can use the shortcuts here also. And if you observe one thing, that here it's written L. So L is basically the keyboard shortcut that you have for the specific command. So if I have to draw a circle, and there's a keyboard command called C for drawing a center diameter circle. So there are multiple 5 ways that you can draw a circle also. Like you can select the center point and then determine the diameter of the circle, or you can select 3 points and draw the circle and all that. So and also one more thing is that I can add these tools to the shortcut or the toolbar also, and I can also create a keyboard shortcut for this. So if I have something like, so I want to make a shortcut, so I can just type in something in this tab. Then, so I'll just draw a circle. So I'll just select a point here and just give a diameter of around 50. Okay. So now I want this circle to be at the center of this. So one way of doing that is like giving constraints. So constraints is basically the rules that you give, like, okay, so I want this center point of this circle to be the center of this rectangle. So I select the coincident. So coincident is basically one of a constraint which tells that this point and like this point are the same, like to be same. Okay. So there are multiple constraints as you see. So like if you go to the drop down, you get, and if you have like if you want to know what each options are, like if you keep your mouse on top of that, like a small description is given on what the option, like function is in each of the functions. So I select the coincident function command and then just select the center of it and select the center of this. So you see that the circle comes to the center. Okay. So if I do one more thing, so I select this 2-point rectangle, I draw something like this. Okay. So here the dimensions did not come because previously we assigned the dimensions. Okay, and one more thing is if you want to stop this tool, so this tool still remains. I just need to click on escape, the tool goes off. So, and if I have to give a dimension to a side, so I want to tell that the length of this rectangle is going to be 50. So I just click on this line and I can tell this is going to be 50. And if I enter, so the dimension is being present there. And if I want to know the distance between this point and this point, I can either select this line, or another option is select this point and just click here. And then you can also either you can change the dimensions to the dimensions you want, like 100, or you can leave it at the dimension which is being there like already. Okay. So these are basic sketch tools. Like you can explore all the tools here. Like, so these are this to develop a circle, arc, like you can have variety of polygons also basically. So I want a circumscribed this thing, a polygon, so a hexagon or something. I'll just click on that and I can select number of, so this is the diameter of the circle inside, and then if the number of sides have to be changed, just a minute. So if I have to change the number of sides, so if I want 10 sides, so this is the polygon that is being generated. Okay, so if I click this, okay, so I'll just go back. And okay, so these are various sketching tools, and these are some other tools that we can use. This is the fillet tool. So fillet is basically like if you want a curved edge, like you don't want a sharp edge at this point, or like I'll use it for this. So I want to curve this edge, so I want to bend here. So I just click on these two lines. So this is the basically the filleting option. So you can actually increase or decrease the radius of curvature of this point. So I can make it like this, or sharp, or more blunt, or something. So even I can enter a value there also, like this. So this is how the filleting, and you can also use an option called like, and so if I do something like this, and I want to okay, so these are the line options. So I have created, like, there is a shortcut, keyboard shortcut L. So if I click on L, and I can use the line options to draw. After that, I want to like remove the line between this point and this point. Okay, so for that I can use the trim tool. So if I select this, you can remove that line. So, and there are multiple tools like the offset tool, where I can select like a circle, like, this chain, and I can actually push it out. So this creates an offset sketch of the whole, the box kind of stuff what we design. Okay, then like that. So these are the different sketching tools. So yeah. So you can, after you finished all, like one more thing is like when you right click, right? So these are the options that you get. So this is basically what you get here is the previous option that you have selected. So previously we had selected the offset tool. So this is the option that we get, and there are multiple other options. You can delete those or undo, or in many other options that are coming. After you finish a sketch, always click on finish sketch here, or you can use this tab here, then just finish sketch. Okay, so you can see your sketch here. So coming to the left, one of the main important things is the units that we use. So currently here we use M for everything. So if you want to change your units, just go to the change unit options, click here, and you can change your units to centimeter, inches, foot, or meters or anything. So currently, like the standard what we use is millimeters here. And then you can also hide your options. There's an option to hide a sketch, like you can hide this and you can view it back. Oh, these are there, like, okay, so okay, even you can delete your sketch if you need, like, so they have right click on this and you can delete this. Okay, so okay, let's start with something solid modeling. So like if you guys are also on Fusion, you can open Fusion and like is anybody doing with me, or like so you can tell yes in the chat if anyone is doing along. Okay, so okay, fine. So let's create a small solid model. Okay, so first you can click on the sketch 2D sketch option, click a plane. Okay, and then we'll draw a rectangle there. So click on the rectangle option, center rectangle, and then click at the center. So when you move the cursor, you see that there's a blue box around. So that shows that this point is at the center of the plane. Just click on that and you can extend. And we'll give the dimensions to 100 by 150. So as you remember, we have given the units in mm. So all these will be in mm. After that, we'll finish the sketch. Okay, so after this, what we want to do is we'll make it into a rectangular box. So so these are the solid modeling options. So there is an option called extrude. So basically you can read through also, like the option, when you go to the option, it's adding a depth to the sketch. So it's basically, so if I click on extrude and just click on the surface, so there are multiple options that come. So when you select any options, you get like all the parameters that are to be given in the right tab. There's a tab to the right. So I want the height of the box to be around 60. So I can either pull this, like there is an arrow, I click on that and I can pull it, or I can give the value here also, like I can enter it as 60 and it will create a new body. Okay, so this is the cube that is being designed. So I want to make a cone at the end of that, so it looks like a truncated pyramid. So I have to construct a plane. So you can always generate a 3D model from a 2D sketch. So what we'll do is we'll create a plane at offset plane. So previously we had 3 planes, so I can show the origin actually. So these are the 3 planes we had initially. So now if you want a plane here, so what we have to go is go to construct offset plane. So I have to make a plane. Just click on the plane that you have to offset. Just lift it. So you want it a height of 300, just select 300 and click OK. So now I'll make a circle on top. So whichever plane I have to sketch, just select the plane. Just select here. Then so circle, center diameter circle. Just select the center of the circle and then give a diameter of around 50. Okay, after your sketch is being done, just click on finish sketch. And you can hide the planes if you don't want to. Like you can hide the construction plane. So to the left, you can see what all options that you have used, like the various planes that you created and the origin, the bodies, the sketches, and all those will be to the left. So you can use those, and then so you can also expand your all the planes and all those, like whatever bodies you have expanded. Like, so there will be a tree structure that will be developed after you complete your design. So depending on your design, if it's a complicated design, you will have a long tree structure to the left. Okay, so I'll just go through multiple options here. That is extrude, revolve. So revolve is basically an option actually if you make a sketch in a plane and you want it to have a circular circular, like you want that plane to revolve around a axis, so that can be used using revolve tool. Then there is a sweep tool, like as you see here, like you need to draw a line and a plane or a figure that you want to sweep through the line. So this is the sweep option. So there is an option called loft. So we'll use a loft option now. So this is basically like, I want to so like join this rectangular planar sketch with the circular sketch. So you just select this planar sketch, and then so you see that there is profile one, that is the rectangular plane, and this is the circular plane. So this is the profile two. So this automatically generates a draft tube kind of figures, as you see here. So yes, yeah. So it's like, and then this is a loft option. So yeah, and then there are other options like the rib and all those, like you can explore later. Like you can, and you can also create a box. Like you don't have to make a rectangle. Like if you just select a plane, just draw the rectangle, like whatever dimensions you want, 100, tab 100, and then you can also set the height little to 100. So this is the rectangle that is created. Like, so without a sketch you can create this rectangle. So these are different bodies that are being created. So these are two bodies, you see. This is one body, like the whole. So like so one more thing is, like when you click on a body, that will be highlighted here. So like the bodies are being highlighted. If you go to the if you go into the tree, you see that this is the body one. So if I click on the body one, the whole body is being highlighted in blue color. So if I click on body two, this is the second body. So these two are different bodies. Okay. Then the options are, okay, mirror option. So this is one of the commonly used options. So we'll explore that later. So I'll delete this body. So I'll just go to the bodies option. Just select delete. Okay. So deleted the body. So these are basically to create the 3D models. Okay, the create options, and then you can go to the modify option. So if you want to modify a solid body, you can go to these this modify option. So there are a couple of tools that are available. So if you want, like the first option is the fillet option. So fillet option is basically to, like if you want to give a smooth edge, like what we did on a sketch, we can also do it on a model also, 3D model also. In the sketch we had done filleting, right? So same thing can be done on the, so I select the sharp edges which I need to be rounded, just push the arrow, like it just, so this is being filleted here. So this is a round that is being, okay, so I just, so just, or if I select a fillet, so this is basically to round the edge. So okay, 10, so this edge is being changed from a sharp edge to the rounded. So basically when you design a product, you make sure there are no much sharp edges and all those. Like this improves the aesthetics, and also like, you know, it makes it easier to work with also. Then another option down here is the shell option. So shell option is basically used to make a body hollow, in case if you want to. So I select the parts where you need it to be hollow. Just select, I just want it to be like a kind of a draft tube. I just select the top plane and the bottom plane, and I give the inside thickness as 2 mm. So this will be the thickness of the shell. So you see this is being changed. Then I click on OK. You can see that this is being changed to a hollow tube. Okay. So I'll just make a small modification in this. So just go back. So now it's a solid body again. So the difference between a solid body is, like in a solid body, the complete this thing is filled. So when you, like normally we make objects which are hollow, like For that, we use the shell tool. So if I just want this part to be open, like a bottle or anything, like just one side being open, I select shell, I just select this face and give the thickness as 3 mm and click on OK. So now you see that it is like a container. So this part is still closed. So the complete thickness of the material is 3 mm now. So as we get, okay. So that is one tool, shell tool. It's like, that is being used frequently while designing. Then this is the draft tube. This is the scale tube. So if you have to, change the dimension, if you have to scale down or scale up the model, you have to use this tool, the combine tool, offset. And then one more tool is a split body tool. So if I have to split the body into two or something, have to use this tool. So I just want to split this into two parts. So the rectangular block as one and the top truncated part as one. So what I do first, I just create a plane. Okay, so just create an offset plane. Select this. I just push it up. The height is 60, so we give it a 60 and then OK. So I'll just split it into two, split body. So I'll select the body and then I have to select the splitting tool. So just click on this, so it will split. Okay, so now these two are two different bodies. So if you see here, this is one body and this is another body. Okay, so we have split the tool. So these are the various modifying tools. And then if you go to the assembly, so assembly is basically when you have multiple components that are to be joined. Okay, so we use the assemble tool then. Okay, so these two are two different bodies now. So I'll just show you, like, if I click on join, an error will come now. So there are no components to assemble in the design. So you can assemble only two different components. You cannot assemble two different bodies. Okay, so we have to convert these bodies to components. For that, just either you can click on each body and then like create components from body. Just right click and you will get this drop down, like create components from body. Or if you want to completely like convert all the bodies to components, just create, right click on bodies and create components from bodies. So there are two different components. So now these are components. So you can see that it's given component 1 and component 2. Just like click once on the component name and you can change the component name. So I can give this as base and I can give it as top, like I can rename it as top. So yeah, so these are the two components. So one thing that you will observe is like you can move the body, like I can move all these parts like this. So before, when it was body, I won't be able to do that. Yeah. So yeah, this is the part. Okay, so let me delete these both. Yeah, so now it will go back to body when I delete those components. So I have to, so I'll hide this in the background. Okay, so I'll hide this. Now let's so we'll make another model which has a joint, like a revolute kind of joint. So we'll start with a sketch. We'll click on the plane that we want to draw. We'll create a circle of 100 mm dia. I'll finish the sketch. I'll go to the drop down. I'll select extrude and E is the keyboard shortcut that I have. So I'll click on that. I'll extrude it up to a height of 30. Okay. Then again, I'll draw one more cylinder on top of this. So what you can see here is I can draw on this plane, on a flat plane. So every time, you can always draw on a flat surface. So this is a flat surface, but I won't be able to draw on this curved surface. So I select this flat surface. Then I'll select the circle tool once more. And I make a circle of around 50 mm. Okay, finish sketch. Then I'll extrude it. 100. Okay, so now one thing that you have to notice is that there the options at the right. So there is an option to either you can start the extrusion from the plane that you sketched, or you can start from an offset plane. So basically, you can start it at a height of 50 above the offset plane. So you have to just select this, and you can just give enter here 50. Just given 50. So this is actually offset at a height. So if you, and the thing you see to the right, there's a cube to the right. So if you click on the cube, if you left click on the cube, and if you move the mouse, you can see that it rotates in different orientation. So you can have a view from different angles, like using this tool. And if you want it back to be in the home position, you just click on the home icon there. Okay, so like let's remove this offset plane. We'll select the profile plane itself. And then in extend also, you can extend to an object. So if there's an object on top and you want to extend it till there, you can use that option. Like we'll look into that now. And there is two operations. Either you can join the body or you can create a new body. So we'll create a new body. Okay. So after this, let's draw a I'll construct a plane offset, like I'll create a plane at a height of at 150. Okay, or else minus 150. So you can give a negative value here. Just click down there. So here the constructions are not visible. Just make them visible. Like so. I've made the construction visible. So for all the options, there are keyboard shortcuts. So if you want to make it visible and hide and all those, you can use the V and H tool, like for those. Then just click on this. I'll draw a circle here. So I use the keyboard shortcut C for that. Just draw a circle like this for diameter 10 or 30. Okay, just done. I'll just sketch it once more. I'll just make the construction one. Okay, I'll make the plane visible. Okay, then I'll select this to draw the circle also to the center, almost to the center, and I make it 30. Okay, so if I want to place the circle to the center of this, I use the tool called project. So I don't need to know what is this like. I need to have this line as the reference. So basically, this is the top cylinder part. So if I need to get the one, I just go here, project. So if I click on project, and if I click here on the top line, I get that line. So you can see here, there's a purple line. This indicates the line, like it's just for a reference. So if I use the line tool, I can draw down. So I get the midpoint. So one more thing is, like when you move the cursor over the line, you can see various, like this thing changes. So here you can see when it's to the center, you see a triangle on top of the cursor. So that shows that it's at the center. And I give a drop down. So I'll drop down to a height of 60. So we'll give the constraint tool, as we said before. We'll go to the coincident tool, select the center of it and the tip of this. So this is to the center now. Okay. So now I feel like it's too low. I have to make it higher. So I'll just click on the 60. I'll change it to 40. So it automatically moves up. So since I've given a constraint, it moves automatically. So if I want to make it 30 also, I can do that. Okay, let's finish the sketch. So now you see that this sketch is away from this body, but I want a cylinder that is being joining to this cylinder. For that, what I do is I just go to the extrude option, click on extrude. So now if you see, I can extrude it to the tips, but then after when I move it ahead, I see that it's cutting through because the operation here is cut option. So we'll explore that actually. So we'll give a cut option. So you'll see that there's a hole in. Okay. Okay. So next we'll go back. So what our objective is to make a cylinder that joins to this part. For that I go to extrude. Yes.
Sir,
Yes.
small
Yes.
doubt, sir.
Okay.
Sir, now you formed a cylinder, and if we cut that, it makes a circle, right, sir?
Yeah.
If we want any other shapes, we can do that, and if we do same cut option, it will become as that shape holds, sir.
Yes. So I'll demonstrate that then. Like, so circle is something that's very common, right? So let's go back to the sketch where we drew the sketch. Okay, so this is the circle that we drew, right? So I'll delete the circle. I'll have a rectangle. So I'll just draw a rectangle with a center rectangle. Just have the center rectangle. I'll do this. Okay, no, we'll have a center rectangle of dimension 40 by 40. Oh, like a little bit lower, 20. Okay, and then I'll change this to 40. Okay, fine. Then I'll just finish sketch. Then I go to the extrude option here. I click the surface. See now, like you can see a square hole, right? So this can be any shape. It need not have to be a geometry itself. You can draw a ellipse or anything like that, or any polygon, or your own figure also you can draw and you can cut it through. And one more thing that you can explore is that, like, so if I don't want a whole pass through completely. I just want it to halfway done. So I can just put it till a depth of 110 and then just see. So there will be a slot kind of this thing formed. Okay. So this is this thing. So as I said, so now my goal is actually to join this part to this. So what I'll do is extrude this part, start from the profile plane, direction and all those, extend till two objects. So if I give two objects, so I'll select the surface. So and join option. So now what you see is this part is being joined to this. So these are two different bodies that, so now you see that because it was join option, this is a single body now. So these two pieces are single now, and so these are the two different bodies. So now we'll make them into two components now. So I'll just click on control, like I'll hold control on the keyboard and just click on these both things, and then right click, and I'll create components from the body. Okay, so now these two are different components. So now I can move that. Okay, so yeah. So now we'll have to assemble the two components. So always you have to assemble the components, otherwise it will move around. So what I'll do is I'll use the join tool here. So click on join, so it will show capture position. So I'll select the center of the circle. So there are multiple points that come when you click the joint option. Just select the center and select the center of this part also. So basically you have to give 2 points that actually coincide. So that points when you give, it joins to that position. So there are various kinds of motions for a joint. So you can have a rigid joint. So basically rigid joint makes it stiff. Like these both are, like, you can take an example of gluing two pieces. That is being done in the rigid joint. So you can animate those motions also. Then the revolute joint. So revolute joint is like so I'll just join it once more. Capture position. Okay. Uh, so first one thing was that we'll have to ground one of the body so that it does not move. So I ground this part and then I'll join this. Click on join, capture. I select this. Then I'll select the center of this. So this is a rigid joint. So this is a revolute joint. So you see this part is being revolving around this part. So if I have to animate, This is a revolute joint. So this is a joint that you see on hinges and all those. This is a slider joint. So based on your application, you can select the joints also, cylindrical joint and all that. Pin joint. There are multiple joints, so you can explore all these kind of joints. So let's click on revolute versus revolute joint. Okay. So that's the part in join. And then, yeah. So any clarifications or doubt till now, you can just ask me, or if you want to me to repeat or go in detail in any of the operations or tools, you can please ask me.
So please explain the offset again, sir.
Okay, I'll explain that in sketches, right? Okay, so I'll create a new sketch. Okay, so this is a sketch. So I will sketch on this plane. Okay, so I'll sketch. So I'll use a circle. So for making it simple, I'll just use a circle. So I click on the center. I click 100. So I want one more circle at a radius of a diameter of 150. For that, I'll use the offset tool. So I'll click on offset tool here. So offset is in the modifier. So click on offset. So I'll select the curve which I want. And I can move it like so. I want to offset it by 30. I just select 30. I will click on 30. So there are two circles. So the circle you'll understand easily. So then one more option if I want a complicated shape. So I'll draw a rectangle. So I'll keep it like this. I'll draw an arc, 3-point arc.
Fine, sir.
Is it okay? Is it visible now?
Only the sir.
What is visible?
Yes, sir. The circle is visible, sir. It's now visible, sir.
Okay, fine. Okay, so I'll remove this line. So for that, I'll use the trim tool. So I'll use the trim. So this is the trim tool. I'll remove this part. So I want an offset of this by 2 mm. So what I'll do is I'll go to the modify offset. I'll select this thing. So if I want to select if I have to offset the complete thing, this chain selection will be selected and selected. Then I move 2 mm. So if I want 2 mm, I'll select 2 mm. Okay. So you see there are two lines that are parallel. Okay. So then, or if just I just want this one to be offset by 2 mm, I'll just go here, offset, remove chain selection, just the arc, 2 or so if I want by 20 mm, I type 20. So you see there's an offset of 20. So this is about the offset tool. So you can either save the option by going to the save and just selecting a look. Yeah. You were
I'm
asking
only
something?
visible that circle, sir.
Which circle like
I'm not visible in any plane, sir. Standing.
okay. Okay, so you just a minute. I'll stop sharing and start again. Is it visible now? Hello?
Sir.
Yeah, is it visible now?
No, sir. The screen share itself, it's not showing, sir.
Okay. No, like in the preview, I can see the screen is being shared. That's the reason. Just you just try logging in again or something like that.
Yes, sir. Now it's coming, sir.
Okay, fine. Okay, so you couldn't see the offsetting, right? So I'll just show that again. So I'll just remove this line. So there's a delete. I click on offset. So if I want to offset the complete loop, I'll just click on chain selection. Click. Now I'll offset it by 20 mm. So I'll just pull it out 20, enter. So this is the offset option. So you get the same figure offset at a distance. So this is the offset option. So even I can do an offset inside also, not only outside. So if I just again go to the offset, or as I said before, if you right click on your mouse, you can get the latest used tool. So it repeat offset. I click on only the semicircle. I just want the semicircle. I'll push it in. I click OK. So you can offset this. So are you clear with this, or like should I repeat it once more?
Yes, sir. It's clear now, sir.
Okay. Any other tool or anything that you want to design, you can just, so next step is like you can tell me anything that you would like to me to design, like so we can do that together. So you can also tell me like what is your progress and we'll go together and design something. Since only less number of participants, like so if you have any other like anything that you like to design a simple version of that, we'll go with it. So you guys can tell me something that you can design that you want to design. Yeah, just tell me, like, just either put in the chat or you can tell me. Yeah, you guys want to like some design
Sir,
that you want to do?
sleeves with quarters.
Huh?
Sleeves with quarter blocks, sir.
Sleeve with quarter block. Okay,
Yes, sir.
let me check for an image of how it looks. Okay. Or you can tell me something that you see around every day also, like anything like that. But could you please share me an image on the chat or link or something of what you are plan like what do you want to see like so that I can just get an understanding of what it is. Hello.
I'm using from mobile, sir. So the chat box has been not available for me, sir.
Okay.
Sir,
Okay. So
can we design a bolt or not like that, sir?
yeah, you can design bolt on it. Yeah. So we'll design that once. Okay. So what we'll do is we'll design a bolt first. Then for creating a bolt, we'll just select create sketch. Click on this plane. So we'll draw a polygon first. So for a polygon, hexagonal bolt head will be there, right? So we'll click on circumscribe polygon. Click here. So this is, so we'll have a diameter of a radius of around if it's an M10 bolt and 10 point something. Okay, let's keep it 11 or 10. Yep, with 6 sides. Click yes. Okay. After that, we'll extrude this up. So for extrusion, you just have to click finish sketch. Go here, extrude. You can extrude up to a height of, I guess M10 bolt will have 5 or give 6 mm. Okay, so the hexagonal top part is being done. After that comes the shaft that comes up. So for that, you can again click on sketch. You will select this plane. So you want to draw the circle from here. So you take a diameter of 10 mm. Okay, enter, finish sketch, and you can extrude this down also. You want whatever length you want, like for example, take 40. Okay, so the bolt is being done. Okay, let's check how to do the threading part. Thread is being given. So just go here, ISO and all this stuff. And you have to just select the face where you want the thread. What kind of thread? M10 with 1.5 mm pitch, or what kind of thread? You can just select those. Right-handed or what class, and because you know the properties of your thread, and you just select it. So the thread is being generated. So the thread is not exactly what you have seen in other softwares. You will just get an image kind of this thing. But when you go for next processing, you will see a detailed image of that. Then coming to the bolt also, it's similar to this itself. Like if I want to create a bolt, I click on
Sir, can
this.
you adjust the length of the thread, sir?
Yeah, that is basically the pitch, right? So if you know the properties of your thread, you can adjust that. So I've
No,
given
sir.
here 1.5. Yeah.
In this, the full part is threaded, no, sir.
Yeah. Okay, I
Can
get your
we?
point. Yeah, you just want a part of it to be threaded, right?
Yes, sir.
Yeah. Yeah. So I'll just make a this thing. So I give 10. I'll extrude this. Hmm, 20. Okay. Just go here. Just click on thread. So one thing what you can do is like you can thread, like you want for 20 mm, you want to thread only for 20 mm. Just select this face, okay, and then you can again extrude from this part like whatever you want to. Okay, just I'm not sure about this. Okay, or else there was another way like, which you can do. That is minus 40. Then I use a split body tool. I split this body into two parts. Okay. So I make an offset of minus 25. Okay. Split body. I'll split this into two parts. So, okay. And then just go to thread. Select this part. Okay. Yeah, so this much part is being threaded. So if you want later, I guess you can combine this both. Yeah, now this is a single body. So it's partially threaded. And if you have a hexagonal head, you can do that. So normally we don't design in Fusion, we don't design the bolt nuts and bolts because the reason is like we can other like there is an option to insert all these. So you go to insert option, you go to there's an option called insert master car components. Just click on that. Okay, so here you get a list of like things that you can download here. Okay, so if I want a bolt, I click on this bolt. Okay, there are multiple varieties. So if I want a hexagonal head bolt, I click on that. So then what thread size you need? You need an M10. You just click M10 bolt. So this is the M10 bolt we have. Length of the bolt 10 mm. And then you'll see the properties of all those. And if you want that, And after that, when you go through, you just scroll down, you'll see CAD for technical drawing. Just click on. There will be the CAD, this thing available for this. Just yeah. Just click on link and then product details. Just click on product details. So you'll see all the details. If it matches your this thing, just save. Step file. You just need to save, and then click on save. Yeah. So you see that model hexagonal bolt is in your design now. Same as this, you can so you can insert any component. So I'll just repeat how to do that actually. So go to insert option. In insert McMaster-Carr components, just click on that. Here you can see whatever you need. So if you need a nut, just click on the nut and a hexagonal nut. Or if you know what exact property you need, M10 or something, just click on that. So there are many multiple materials and all those stuff. Let me click on this. And like if you go through all the properties and if you know how to find a nuts property, just click on any of these. And product details. Just if you just make sure it's in 3D step file, save it. Just wait for a few minutes, it will come. Yeah, so this is the way how you have to move the components. So either you can click on this, then you have an option to move it around, or you can use this tool to move it in a specific axis if you want. You can also rotate it around like this. So all these you learn by doing this things. Okay, so in the chat, can you explain sweep command? Yeah, sure. I'll just close this. So if you have to save it, just this is the project that just a minute. So this is the project that I've made, right? Like initially I showed you how to make it. So just close it. So when you close it, you'll get an option. So save it. I'll just put bold as a name in the location. So if you have some other places, just select the other options. Okay, just make sure and save. So it'll be coming up here. So you see that the bold option is here. Okay. So I'll go with the sweep option. So I'll sketch on this plane and you can select any plane based on your liking. Okay. And then I'll just, first I'll just create in something like a donut or something. I'll just create a circle of diameter 30 or into, then, okay, one more thing I just have to do. So you can just change the orientation and which you'll see it. I'll draw a line at this point. Okay, I'll draw a line. This is just for a reference. Okay, just this line is for your reference. And just go to the, okay, first I'll show you revolve, then I'll show you the sweep. So click on revolve. I select the profile. So this is being already selected. If it's not being selected, just click on this. The profile will be selected and the axis. Either you can select the default axis being given, the origin axis. If that is not the what you want, you just say click on this line. So you see that it's a room, like a a donut is being created. Okay, and if you can also change the angle that you want to, like if you don't want to complete this thing, you just want it for 180 degrees, something like that, you can go with that. Okay, so that is one design. So coming to the sweep option, yeah, I'll just start that. So I'll just delete the sketch. Okay, so once more I'll just draw the circle 40, enter. Okay, then I finish the circle. I'll draw one more, just yeah, and I'll draw a spline. Okay, so I'll explain you what I'll show you how spline tool is. Fit point spline. I just want this point, but I'm unable to get that point. Okay, so either you can select this. Okay, or this point is there. That I'll just select that. Select like this. So this is something like a free body. So you can, like, this is a free line that I can draw. After I finish this, just click on this tick mark. And if I have to modify this, so after doing that, just click on escape. So the tool is being changed, like, and then you can see actually modify the curve of it and all those. Okay. Or if I want to move a point a little bit away or something, you can use this point. So this is for spline. Okay, you can just get a freehand drawing. After all these things are done, just go to the option, sweep option. So first you have to select the profile that you have to sweep. So just select on the profile, then click on path. Path is basically the path followed by it. So I just click this line. Okay, so you see that the sweep option has been done. Okay, so for getting complicated shapes and all this, you can use the sweep option. Yes, this is the sweep option. I guess, yeah. Or if you want a different path, I'll just make a different path and show you. Or I'll have a reference plane as this path. Okay, so I'll just project this. So for projecting that line, project, just click on this. Okay. I'll just make a rigid line this time. So I'll make like this. I'll go like this for 100 just 100 mm. Then from here to here, a 45 degree, 100 mm of 45 degrees, tab 45. Okay. So I'm using the keyboard shortcuts most of the time for the line tool and also 100 mm. Then finish sketch. So I have to sweep along this direction. Just go down here, sweep this, select the path, to create the sweep. I guess, is it clear or like should I explain once more?
Clear, sir.
So yeah, so it's clear, right? So what is the next thing? Can we design any type of complicated design like coupling, etc. in AutoCAD with 3D modeling? Yeah, sure, you can design, like, yeah. So this is just an overview of how to do that. Like, okay, so yeah, just a minute. I'll just have a sip of water. Yeah, so we'll have a basic coupling design. So I'll design a coupling. So don't save. So we have a universal joint. So we'll design a universal joint that can be done. So we'll sketch a point. So for universal joint, there is a center link that you will have. So we'll design the universal joint. For the universal joint, first we'll design the plus joint link that is there at the center. Okay. For that, circle 10, 5 will be there. Okay. Finish sketch, extrude. So just a minute. Yeah. So when I select extrude, I can either extrude it in one direction like this, or I can extrude it in both the directions symmetrically. So these are the multiple options that are available. When I do that, there is an option to extrude it symmetrically. So I'll extrude for a height of 15. So each side in total it will be a length of 30. Okay. So I'll extrude it like that. And I'll also draw a plane and draw in this direction. Circle, same as before. Diameter is 5. Enter. Sketch. So I'll hide this body for me to get access the sketch. So I'll click on extrude, symmetric of the direction. So I'll make the body visible so that I can see what I'm doing. So this should be to a height 15. So now you see, like previously I said, right? So it shouldn't be a cut, it should be a join object. So we have to change this to join. So now we see that plus there. Okay. So the next is like we'll have to make a clamp for this. Okay. For that, what we'll do is we'll draw on this clamp. Okay. So in this, I'll just need to have I'll get this point. Project this point. Okay. So this will come up to a height of like 10. Okay. Like higher. Sorry, just 5 mm. It's too thick like this. Just make it 2 mm. Okay. I'll just draw back. This is, I'll make it 2 with this thing of 27. Draw a line from this. Just click on this. Okay. I'll trim the excess line. This. Then I'll mirror this here. Yeah, or I'll just join it. Trim this part. I'll finish the sketch. I'll extrude this. I'll extrude it symmetrically. Okay. But I'll extrude it for 10. Okay, so I'll make it a new body. Okay. And what I'll do is I'll give a fillet to these. So these corners are sharp, right? I'll make a fillet for them. This part of select the joint, give a good fillet, make it round and clean. Okay, so 10. Okay. So it should be all. So one more thing is that you have seen is this part and this part. Can you see this is actually interfering this? So what I have to do is I have to put a hole on this. So there are multiple ways you can do that. Either you can project this part, make a circle here, draw, and you can put a cut. Or there's an easier way to do that. So you can use this combine option. So in combine option, if you go click this, you have to select the target body. So your target body is this, and your tool body is this. So what it does is it removes the part wherever it interferes. So instead of join, just put cut, keep tool. So you want this tool, so just keep it. Okay. So what you can see now is there's a hole being created there. If I go to body, if I hide this part, so you see the hole here. Okay. I put back this. No, but still you find that this is not yet complete because you want the bottom part also. I use the mirror option. Mirror option is there in this. So go to mirror. From here faces, so you can mirror face, body, sketch, features and components and all those. Just click on body, select the object that you have to move. Okay. Mirror plane. So you have to mirror about this plane. So just click on this. Okay. But one thing that you see is these two are different bodies. So I'll combine them. I'll use a combine tool. Instead of cut, I'll change to join. Yes. Okay. So now this is into one body. Okay, this is one body. Okay. Just delete this one. Okay. Just I'll just combine it. So yeah. So just remove the tool. So you see one side of the universal joint is done. So I'll just make a replica of this one soon. So that's what I'll do is I'll convert this into components first one. That will make it easier. Create components number. These two are two different components. Okay. I'll just make a replica of this by knowing like which is this component. So this is component number 2. Let's make a copy. Then again paste it. Capture position. So a replica of this is being made. So what I'll do is I'll just rotate it by 180 degrees and also rotate it to this axis. Then I move it back. Then click on enter. Okay, so now all the parts are being done. So now what we can do is we can assemble that. So then join. Click on this part, and the type of motion is revolute motion. Okay. and I click this part, this part. That is also a relief function. Okay. So this is basically so for our reference, we'll ground one of this. So we'll ground this. So position. You can actually move this around either by moving it like this, or you can just click on the link. You can move it around like this. So you can see this is moving around this axis. Also, this is moving around this axis. Okay. Yeah, so this is the universal joint that we have created. Yeah, so that is from that part. So let's go to another topic that is actually applying materials for the for a body or something. So what we can just do is we'll just make a simple cylinder. Okay. For that circle, and we'll extrude it to a height of 100. Okay. So by default, Fusion 360 uses steel as the material. So I'll change the material to something else. So we'll go here, we click on bodies, right click on bodies. Here comes the option called physical material. So we click on that. So a drop down appears here. So there are a list of materials that can be used. So I just select, just go with metal. In that, the aluminum also, there are a variety of aluminum. So I'll just drag and drop one of them. So you just have to right click, left click on it and just drop down the body. Just close it. Okay, so if I go here again, go to properties, I can see what is the surface area of it, what is the density of the material that I've used, what is the mass of the body, and all this volume and all those stuff, physical material, moment of inertia, center of mass, and all those things. Okay. So if I have to visualize the center of mass, okay, so that can be done. Go to inspect center of mass, click the body. Okay. And this point you see is the center of mass. Okay, and then there are quite a lot of tools that are available. You can measure the distance between this and this using the inspect tool. And you can have a sectional analysis. So in case if I shell this, okay, I shell it up, base of body. 3 mm. Okay. So now the mass of it changes actually. So if you go property, so the mass has been reduced to 300. When one more thing is the CG also shifts slightly, shifted down. You can also have sectional analysis. So if there are multiple components, it will give you further. You can see the sectional analysis also. You can just select a plane and move through and see the sectional analysis part. Okay, so for this thing, I just want, so I'll just take this piece alone. So what I'll do is I'll hide the other pieces. Okay, so this piece alone, I'll hide the joints also, sketches also, everything. Only this piece is there. So sometimes when you design something and you're going to the manufacturer, so you're going to just a workshop or something and telling them how to make this. So you want to make a clamp like this and you want to tell them how to make it. So you have to show them a drawing. You don't have you cannot express them using a 3D model. So what you'll have to do is you have to make a drawing of this. For making a drawing, what you have to go with, either you can go to the drop down here, drawing from design, or you can go up, new drawing from design. Okay, just select that. So I have to save this before that. I'll just save it. After I save this, I just click on select, and then I just select this part, and the paper and all the size of the paper can be selected here. And click on OK. Just wait for some time. This it will take some time to go. So you see your body, it's in one oriented. So if you want any other view, like you want the top view, I guess, like so this is the top view. I click here and the type of frame and all you can say how you want it visible edges, just edges or want it to be shaded. So let me check. Normally we use this thing, this option, second option. You can scale it up and down and click on OK. You see this thing. So if I have, but just by saying this, nobody can understand what it is. So I'll just check the projected view. Click on projected view, select the object, and based on the angle at which you're viewing, you can select the different orientation. Just select them, click at the. So basically, this is the back part, and whichever orientation you want, like from the view, you can understand. You can just just like whatever you want to understand. So normally you just need a 3 to 4 diagram. So this is basically the sketch that you later on you can move this around and all this. Basically like this. Okay. And after that, but still you don't know how what are the dimensions or anything. For that, what you can do is just go to the dimension tool, just select the edges, select the edge, apply the dimension like the whole layer. Just select. So by giving a sketch like this, manufacturer can understand how the model is actually. So where these dotted lines are not visible and the continuous lines are the visible edges. So you can, after doing this, you can export it to a PDF. So like okay, and then you can export it. It will be saved in your local computer. So let's close this part. So one more thing was here. So I've made a model like this. Okay, so I need to save it in my local system, or I wanna share it to a friend of mine. I just wanna mail it to someone. So what I have to do is I have to actually export it. For exporting, just go to the file drop down, click on export. Just put the name of your file, what you want to put it as, like CAN. And what format? Like, so in designing, there are multiple formats. So F3D format is a format by Fusion 360 only. So if they are using it, opening in Fusion 360 itself, you can send it in this format. Or the commonly used format is a step file. Step file is a file used by SolidWorks. So SolidWorks is another designing platform. So if you have to send it to someone who will be opening in SolidWorks, you can just send them in step file. And STL file is one of an important file that we use. Like that is basically used for 3D printing and all this. So basically, you send an STL file for 3D printing. So basically, it's a set of meshes. Like so, if you can explore something like what are meshes, so it's like it converts your complete model into small triangular shapes, and then the complete this thing forms into a solid model. So STL format that doesn't carry any of your appearances or the measurements or anything, but it'll so when you export it, so if you want to open it in another system and redesign it, you shouldn't send it on STL. So you have to always send it on a step file or a F3D or IGS and all that. So STL format is just used for 3D printing or any other. If you're designing a robot and you want it in your simulator or something, you have to send it in STL format. Okay, so it just click export. It will export into your local system. And then coming to so I'll just show you how all these simulations are being done. So like basically the structural analysis, static stress analysis and all is being done. So I just develop a basic L clamp. So basic L clamp. That I just draw a rectangle here, 5 mm, 10 mm. Finish sketch. I'll extrude it. And I'll draw on this thing up. I'll draw it on this thing. And 2 point. So this is the clamp that we have designed. So we'll simulate this clamp. So some of the, if you have to do some of the operations, you need fewer than 360 credits. That's something that you require. So we'll do static stress. So if you don't know what are the different types of simulation, you just can click on that and you can have, there's a small description given on what it is. So normally we use static stress and create study. So always when you change the environment, the top part changes. This is the simulation environment. So we'll apply material. So study material. So currently it's steel. You can either change it also. You can just go drop down and just change it. So currently we'll keep it as steel itself. Okay. So if you're familiar with simulation, so in simulation, what happens is actually we give a point will be fixed, or there will be a constraint to that. So basically, if you consider a L clamp or something, one part of it is being mounted to the wall or something, another part you apply the load. So one part which is being mounted to the wall, we give a constraint. So we give a structural constraint. We give a fixed type of constraint. So a fixed means you can't move in any of the directions. So I select this face. So this face is fixed. So when it is fixed, you see a lock symbol there. Then I apply a load, structural load. That is the load that is being applied. So I'll apply at the corner of this. So we'll add a load vertically acting in y direction. So I'll just apply a 100 Newton load. So that is good. So as you see in the arrow, it's going upwards. So I'll just change the direction of it. Just put a minus there. And I can change the units if I want to pound force or anything like that. Dyne or pounder. Okay. After this is being done, this is a very simple simulation that I'm showing. So just pre-check on this. Okay. Then click on solve. So you can either do it locally or you can do it on cloud. So this local means it will run on your local system. If it is on cloud, it will run on their cloud service. So I have unlimited credits, but then you might not be having that. Just solve it. I'll save this also. So I've saved it. So it will do on cloud. So it will show the status here and here. So after it's being done, it will be shown. Okay, so it will take around 2 to 3 minutes. So by then, I'll just take you through some of the projects that I've done and few. Okay, just let's finish this. Just wait for some time. I'll just close this. Okay. So this shows in red color. That shows that the minimum factor of safety is 0.99. So that tells us that this product will fail at that load. Okay, so let's close this. So we can also analyze where the failure point is. So this is somewhere that shows that the failure might happen. So just check how it is. Yeah. So this point you see here, right? It's in red color. This shows that this point is like it has the least factor of safety. So if I this is the places where I know which is safe. So the dark blue, this gradient shows where it is safe and where it is unsafe. So this part is actually the failure doesn't happen in that part. The failure actually happens in the red part. So if I just want to know where failure happens, just scroll down the gradient. So I can see somewhere here. Somewhere here the failure is happening. Okay. And there are many things that you can, these are just one stress. Factor of safety is one constraint, so you can check stress also. There also you see that this is very high stress here. So you can either change your design parameters or you can actually change your load also here. Like if you go here, load, just click on this force. You can edit it to like, you can decrease the load to 10 newtons. Okay. And then again, you have to click on solve. Again, it will go on cloud. Just wait for a minute. So if you guys have some questions or some clarification, please ask me. You can put on chat also.
You change the colors, no sir.
Yeah.
Only one color showed on the no sir. How did you do it, sir?
Okay, so this is the new result. I'll just show you this. Okay, so this is the factor of safety. Okay, looks. So what this color means is it's not just an appearance or aesthetic. So this is basically shows the result of your analysis. Okay, so in any simulation you do, you see the result in color, so you can understand that. So this here, so I'll just change this to safety factor. So this shows this color, right? So this shows like if it's high, 8 plus means it shows that it's very safe, and it's a gradient basically. So if it is 0, it will show in red, and if it is in blue, it shows it's safe. Okay, so if it is in red, it basically means that the place which might undergo failure is that place. Okay, so I can change the color by just scrolling down the gradient, just left click on the arrow at the left, and I can change. So if I want to analyze where is the green color, I just move it around to that. So since this is very safe for 10 newtons, but it was unsafe for 100 newtons. Now I check the stress. So in the stress also you can do this part. Like, so I just want to know where the maximum stress is. I just go high. I find that this is maximum stress point. So just by dragging this, but basically it's an understanding of where the maximum load is or where the maximum stress is happening. So that's for analysis, but there's a color gradient given. So here you can know that the maximum stresses at this point, and the unit is like the maximum stress is 20.82 megapascal. So that is the conclusion. And you can also see the deformation also. If there is a deformation, it will deform like this. So this is not the actual deformation. So it is actually a multiplied. So if it's an actual deformation, it will be like this. So there is no deformation actually. So if there is, we can like it's just an exaggerated deformation in that. Okay. So any questions or anything? Like, or you want me to do anything that is anything from that? Or we'll just we'll wrap up the session. I'll just show you some of the design works that I've done on Fusion. If that is okay. Like if you have any questions or any clarifications or something, you just you can ask me. Anything? Okay. Okay, I'll move to the design works that I've done. So okay, so it's a blank screen. You can see a robot, right? Fish robot. Hello. Yeah, can someone respond? Like, are you seeing anything on the screen?
Yes.
Yes, sure.
Yeah, so this is a fish robot that was designed for a competition by me. So this was completely done on Fusion 360. Like, so if I tell like what are the tools that I used, so this was the complete red part was done on loaf tool, and it was extruded. Then I shelled it, and then I just assembled the joints like using the joint tool and all that. I've assembled. So you like so I've done this is a rendered image of that. So when you after the model is being done, you go to the render environment and render the image of. This is a rendered image of the fish. So I put all the actual actuators that you find like the servo motors and all those inside, and I've developed this fish. Then comes this is another robot that is to deliver food and all this stuff in hospitals. So this was a design done to you know during the corona time to deliver food and all this. So this is a robot that is being developed by my company. So this is basically to lift and to turn patients in hospitals. So this is a hydraulically actuated robot. We have this and all this. So these are also rendered images of that robot. So from various angles, you can take a photos and take photos. It's just a sanitizer dispenser that was designed. So you can say some products look like actually how it will be in the actual environment. This is a small mechanical part that was designed. So it's like this is a quadruped leg. So you might have seen all these cheetah and all those stuff. So how they designed the leg. So this is a very detailed design of the leg of a quadruped. So this is one leg of the design. So I've designed all the. There are two servos and a clamp that holds it and all this stuff. And I have applied the material like carbon fiber as the material and the 3D printed part and all those stuff. So this was one of the designs. Then this is also a new product from my company. So this is also to deliver food and hospitals and all that. This was a underwater vehicle design recently during my internship with IIT Bombay. So that's also. And this is a drone that we designed, like my team designed. It's a single propeller drone and all this. So all these designs are done in Fusion 360. So after designing this, we actually 3D printed the complete art also from directly from Fusion. This is how it looked at the end. So one thing when you design is like make like know that how will you manufacture. Just don't design anything. Like you know when you design itself, you should like think of how to manufacture or like those stuff. So this was a detailed design that we designed and directly we could manufacture that. This is the fish design I showed before it. So this is an option in Fusion to do motion analysis. So it can also be called kinematic analysis. So this is that process. So I'll just show you how it is. So you see pens is moving around, right? So I've taken a screen recording of that. So you see the joints. So there are joints and I've given the motion for the joints. This is called kinematic analysis. This is also being done in the software itself. And then next, so this is an animation video of the fish. So you can also make small animation videos on Fusion. You can have a 360-degree view and all that. Okay. So any questions or anything that I have to show you or take any questions? So like if you are actually interested in like, learning Fusion and all those, like this is just to show what can be done and how is it to be done in various tools. So you can explore Fusion by yourself. So I've been learning Fusion for the last 4 years. So every day is a learning. Like when you do new things, you learn new tools. So initially, you can learn with the basic tools that I've shown today. So the Fusion has a good support team also. Like if you need a help or something, you can ask in the support. Or there are plenty of resources. So you can go through all those resources. They have like plenty of videos, YouTube videos, and like blogs on how to do design something. So you can go through those also. And yeah, you can connect with me also if you need some help or some like if you're like some design help or something, you can just contact me also.
There's one question, AB, in the chat.
Okay, just a minute, I'll check that. As of now, no. There's no fluid dynamics simulation in Fusion 360 right now. And I like the simulation actually fluid dynamics is not the sorry, Fusion 360 is not the best simulation. Like it's not that great for simulation actually. So there are other software like ANSYS that is available. And in specific for fluid simulation, you can use ANSYS Fluent. But all these are paid softwares. Like they cost you around 15 to 25 lakhs for license per year. So these are there is, and those are quite heavy softwares. And Fusion is a light software because you can use them it's a cloud-based software, so it's not running on your local system. So that way, Fusion is a light software; it can run on any system and all this stuff. So simulations. So as I said, you right, as I showed you, like there are simulation it is done, but not fluid dynamics as of now. I guess they will be developing something soon. So simulations currently available are like thermal models, model frequency, structural, and all this stuff is available now. Probably they might develop something in future. Yeah. Yeah. So any more questions?
Great. So thanks, AB. So you can reach out to AB. We will share his details later. Reach out to him if you have any doubts in the future.